This is Frederick from Tektronix, and this time I'm gonna give you a little bit more insight if what we can do with the RSA and the SignalVu-PC software. So while we're talking here, you can see my screen setup, but basically I got a few questions about spectrum monitoring and how you can take a snapshot of the environment and compare that to live data, and if it's possible both in real time and non-real time. So the answer is yes. You can see that I'm looking here, I'm sitting in Europe, I'm looking at the 400 megahertz span between 750 and 1150. This is how the normal spectrum analyzer would look at this trace. We can go to trace 2. Trace 3 is a peak, but it doesn't really matter. What I wanted to see is this one over here. So here I did a setup where we do a reference scan in real time. You can see the POI is probably pending because my PC is not that good, but pending between 100 microsecond and up. And at the same time we do a mask testing. So this setup I do here is a very simple setup really. So I kind of take a snapshot of a trace in peak hold real time using one of those traces and save that as a reference. And then I take another one, similar setup, and I have math. And what I do with the math then is I subtract the the scanned environment versus the live data. So I'm start doing this, which is related to finding new signals coming in. I have a little bit of signal generator here. I can show you. I just put it on and it should be very visible. And of course, when you do the setup like this, you have the markers. I can go from markers to peak. I can go to the next one. So you see that I have something around 870 megahertz. It's a little bit of a signal generator I do. So let's now start. How do I do this? So I clear this one, and we can see the trace is a math trace. This is the trace. I can show it on and off, and use trace 1 minus trace 2. So if I go to this one and look at the traces, we have trace 1, which is peak and hold. Fine. We have trace 2, which is the recall trace. So if I want to do a new kind of reference, I can take this away, show this one, and save trace, and call it peak. Just over. And yes, we want to replace it. When that's done, I can show the recall trace again and press clear. In this case, it means that we have just collected a new 400 megahertz, and of course I go into preference here and maximize the points. So this is really working to getting new signals. On the top here we have the mask search tool. It's good just to see that you have any violation. You can do that very thoroughly, or like I did, a little bit quick and dirty. But on the tools on the mask search, you have search in the DPX math. It's outside mask. So if I do that, I edit the limits here, and I can select the trace I want here, and then I can auto draw. So if I take a margin of 10 meg, auto draw, it's a very simple tool to be enabled for you to quickly check. So for here example, there is a huge signal here, and if we clear this away, we will probably see that it's not there anymore. So this is the basic idea, and this setup here I've found to be very working when you try to see if there's new transmitter coming in or something. Downside, it's a peak detect based only. I tried to do some averaging. It's a little bit more complex, but now I would like to do the same settings as we did here around 950 and work with 40 megahertz or below. So we do a preset here. We go to 950 megahertz. We go to the ref, and this is the other one thing that is new here as a preamp. I'm running the 500 series. So this is basically what we see here, and I think this is a good example of what's in here. And for those of you who are new, we go for the DPX as well, just to see how it works. So trace by trace, we can see color coded, we can see some content in here, and it basically works. So we're going to concentrate on doing advanced spectrum survey on this one. Go here, click this one. The first thing, not to confuse everybody, I take the bitmap off. So I'm starting working with this trace. This trace is the normal trace. Here, it's the trace 1. We can also do what we call averaging. So this is what I'm going to do. I'm going to use this averaging, and I'm going to save the trace as, maybe we can go down. Preferences, a little bit more points. Don't think you see any difference. You see that on the trace, so it's just a bit slower. And we go a little bit down in resolution like this. Parameter readout, we can see it's a bit 3.3, 2.1. But that's okay. So we have the trace here, and this is one, and we save trace as DPX. I just call it DPX. Overwrite. So this is the first thing we do. And then I just show recall trace, and we have the DPX, and I select it. So now I show this one, and then I go for trace number 2, and I set it up exactly the same thing as I did, and I can show that one. So we have one trace. What's really interesting now is to see the difference between those traces. Here I do averaging to see also that this signal is getting stronger or weaker. And then in the bottom here we go to math trace, where we have trace 1, that is our reference, minus trace 2, and I show that as well, and we go for auto scale. So this is what we can see. So if the power goes up, we can actually do trace 2 minus trace 1. So now it's a little bit stronger and weaker. And of course we don't need to see these traces. I can go to trace 1 and I don't need to see them. And then I went here to the scale and I put like 30 and maybe 15, something in the middle. So now I'm sitting here, we're looking at this, we can see the changes up and down. We probably can tweak this down to 20 dB if we want, and then we have that 10. So if I move around now my hand in the air, you can see things kind of moving because my antenna is right next to me. So I push the antenna, I grab the antenna, let go, grab and let go. So this is the way you can then see changes. And what I also did in this one is go for the mask search here, and I search for the DPX math is outside, and I just added the limbers. But this time you can have upper and lower. Now auto draw, and I get something, maybe 3 dB. Yeah, but we should probably have 1 meg here, so we get something. Auto draw again. Okay, done. So that means I have a kind of a stable signal, and this is what I like. So done. And then we can enable the test, and from the actions here you can do whatever you want. But this is really it. If I'm moving around now, you will see I can put things in the air. So this is the first thing to actually spot things. Second thing you can do here for advanced spectrum monitoring is to do a split. Not only do you look at the changes here and you highlight them, because the highlights will also, you can have a kind of an indication where it happens. Next thing you do on this one, this is the real time, but then you want to have a long term also, you enable that spectrogram as well. So here you go to the settings and you have time and you have a spectrum instead. So that means you have very, very, very long term, and you update it once a second. So this would be, as I call it, a very nice way for you to really work on spectral monitoring in terms of losing or gaining signals in the spectrum of interest. And lastly, of course, all these things can be changed. You can go in here, You can change the amplitude scale if you want to be a little bit, you know, remove some of the effects and put it also, I think it's not, maybe like this. And then you can do the same here, amplitude scale, and you can put this at the same. So hopefully this initial video, how you can work with traces and math and use this as an advanced spectrum monitoring is great. So thank you.
Find out more at Vicom's website.